Okay, so sorry about that. Hopefully it will be fine from now on. Uh, okay, so now let's go back to what we have for the class. So basically in this class, we will learn how to design and how to analyze an algorithm to be sure that we have a good one, right? So if we don't have a good algorithm, then apparently, nobody want to buy it or nobody want to use it. So if you look at the web browser, so in the past, there were many web browsers and then many let's say search engines like Yahoo, right? And then Netscape, and then Google Chrome, right? But Google has a very good algorithm, what they call ranking algorithm, and that's why Google has been the leader in the area of search engine. So that's why we want to know, for solving a problem, how can we write a good algorithm? How can we design a good algorithm? Okay, and also in order to understand how we can design a good algorithm, we would have to learn some basic algorithms. Like here, when we learn in this class, okay, so we will have the okay, can you see the share document? If you want to see it bigger, then you can just pin that one on your screen. Then you will see it bigger than the other windows, right? So in this class, we will learn some fundamental algorithms, how to design a good fundamental algorithm like sorting. Okay? You learn a lot of sorting algorithms, right? Uh, can you can someone give me some names for sorting algorithms? Okay. Bubble sort, quick sort, merge sort, insertion sort, right? And many more, like selection sort, sinking sort, right? And then quick sort, heap sort, right? So many sorting algorithms. So which one should we use when we write a program for sorting? Okay. So we need to know which one is the best, or which one is good and which one is not good, right? So for example, insertion sort and selection sort, they are simple, but in the real world applications, nobody want to write that algorithm for their software because they work so slow, right? So we will go through those algorithms to see uh, which one is a good one and why, right? And also we will pay attention to how to design a sorting algorithm. Okay, for example, I will pick some examples like insertion sort or heap sort to see how we can implement them, right? Okay, very good. And same thing for searching, right? And you will also learn some advanced technique like dynamic programming. Yeah. Dynamic programming is a paradigm or an approach in that we use some certain techniques in order to design a good algorithm. That we use a lot of dynamic programming in say computational biology, right? And then also for data mining, etc. We use a lot of that dynamic programming. So we will learn the dynamic programming techniques, and also you will learn some say advanced computer graphic algorithms. So something like a grid D algorithm that is used quite often in graph theory. And finally, we will learn some up-to-date, very advanced algorithm that you can see on the shared document I have on the screen. That is the computational algorithms for blockchains. Okay. How many of you have heard about or tried or actually use the blockchains like Bitcoin or Dogecoin? If you remember about Elon Musk, then he is talking a lot about the Dogecoin, right? And the Ethereum also. How many of you actually play with those blockchains coin? Okay, so someone have some Dogecoin, right? Very good. So we will try to use the fundamental techniques in algorithm design and analysis uh, in order to understand how the blockchain or the bitcoins work, right? And why we think that is a safe place or a safe algorithm for people to use their blockchain coin, right? So that is, that is very, very interesting. And you will see the power of algorithm design here. Okay? There are many, many coins nowadays. So which one is a good one, right? So, and also, I hope that by the end of this class, if you are interested, we can work together. I can have a project in that we can design our own coin. That is what I intend to do. Okay? So basically in this class, I will try to give you some fundamental concepts together with state-of-the-art algorithm like the blockchains, etc. Okay? And now the second question I have for you is that when you design your algorithm, your program, how do you know that your program is correct? Okay? Can someone tell me that? How do you know that the program you just finished is correct? Okay, let's see. John Chuban, how do you know if your program is correct? Okay, that's it a lot. All right, very good. So actually, is what programmer would do, right? Test, but how many tests are enough? Okay, so that is what you said here. Like I want to test it, okay, to see if it's correct. Say I give some input and let the program runs and see whether or not the output is correct, right? And but the question is, how many tests are enough? You know that for a program, right? For a program, so if you have a program here, say even the sorting algorithm, right? So you have the input and you have the output, right? So the sorting algorithm, how many input you can have for your program? infinitely many, right? Let's say I have an array of 10, 100, 1 million, 1 billion elements, right? So it has infinitely many different inputs. So we cannot test on cases, right? To see whether or not the output is correct. Testing that with, if we test all cases, we never stop finishing testing, right? So that's why in software engineering, you learn a lot of techniques. And also we have a lot of techniques for testing program, like black box testing, white box testing, etc. Right? But here you will learn some fundamental one that is for showing or for proving whether or not the algorithm is correct for every input. Yeah. So that is the technique. Sometimes we call it induction, but induction can only be applied for small algorithm. But for the real world application like operating systems, etc., what we will have, I do not cover in this class, but if you are interested, then I can give you some more information about how to show that the algorithm is correct. It's what we call formal verification. Formal verification. Or sometimes we call it model checking. Okay? And this one is the state-of-the-art approach for showing that the algorithm is correct. We will learn a little bit here for showing whether or not the sorting algorithm is correct. But I will leave this one open because actually I have a class to cover this one. It's called formal verification. Okay? The third thing I want to mention here is about extra learning for algorithm design. You know that every year, Southeastern, we select a programming contest team to taking part in the South Central USA programming contest for universities in Louisiana, Texas, Oklahoma. And in the past, our students did very well. And in fact, in 2018, we won the contest for the whole, state of Louisiana and some university from East Texas, like Lamar University. Okay, so I will start giving some extra, a little bit hard problems for students who are interested in further improving your programming skill, so I can train you more in order to take part in the next programming contest. Okay? And then usually the contest will start in October, by the end of October and beginning of November. So roughly speaking, I will start training the programming contest team by the end of the middle to the end of September. So I have a question for you here. Okay, if you have a cell phone, right, just scan the QR code and it will bring you to, say, a Google form. In that, I will ask you what day and what time is good for you. So basically, we have a training 1 hour per week. And I will post the problem before, and then during the training time, I will go through the solution with you and will ask you to implement the algorithm after we discuss. So, and then that one, that training is different with the course you are learning. But if you can finish, say, the programming contest problems, then you will have some extra bonus points for this class. So usually I will give about 5 bonus points for each additional, say, contest programming problems. Okay? So scan the QR code and just fill in, just click in that, and I will know which time and which day I should reserve in order to train the programming contest team. Okay, so like I have it here. So I use my cell phone and then I scan the QR code. Okay. And just fill in. So I know when we will start the training. Okay, so I will post the QR code on the on Moodle, and if you need to think about that, you can do it, say, until next Tuesday. Okay, so let's talk a little bit more about what we need to prepare or what we schedule for this semester. Okay, so I have a tentative schedule here that I share with you on the screen. Can you see it? Okay, very good. So we will start from next Tuesday, right? But today I will mention a little bit about what you need to prepare before the class on Tuesday to make our lectures more efficient, right? So I will have the exercise number 1 with the due date on September the 1st. But next week, after the class on Tuesday, I will post the question for the exercise number 1 so you can start working on that, okay? Then we have test 1 in week number 4. So basically, we have it here. Test number 1 on September the 15th, and then test number 2, October 13th. In the between, we do have some exercises, and also before the test, I will give you some practicing questions for the test. So basically, I will give you some topics so you know how to prepare for the test. And usually before the day of the test, I will post the solution for the practicing question so you know if you miss anything, right? Or you can compare with your solution to see if your solution is good or is the best, right? So the point here is that I will try to post the lecture notes on Moodle about a week before the class. And in the class, I will not read through the slides. Okay, I mean, you don't need me to read through the slide, right? You can read much faster. And what I will do in the class is that I will use the whiteboard here and go through some actually hands-on problems so you understand the concept better, right? So that is the point of having the whiteboard. So I will explain to you what are the main points of the theoretical concepts, and then we go through with you some hand-on exercises so you understand the problems better. And the exercises, please do it by yourself. It will give you the opportunity to learn more, understand more about the concepts. Okay? For the test, I will try to use the similar question as I gave for the practicing question before the test. So about a week before the test, test number 1, test number 2, and the final exam, I will give you some practicing questions. For the test, I will not use exactly the same, but similar to that. So you have to be able to understand how to solve the problems in the practicing question and in the lecture notes so you can finish the test the best. Okay? For the test, we will have to use a Google Meet. Okay? So I just want to be sure that you work on the test by yourself. So that said, I saw that some of you already took some virtual class from me. So during the test, I will basically ask you to turn the camera on so I know that you are working by yourself, right? And when you finish, submit it to Moodle and turn off the camera and leave. That's it, okay? For the final exam, I follow what the university has for the final exam, that is December the 6th from 12:30 to 2:30 p.m., right? And for the lectures, I will have it from 3:30 to 4:45 every Tuesday, Thursday, again, excluding the break or any of the holiday, okay? And hopefully that the problem with, I will check back the computer to see what happened today with the microphone, but be sure that nothing like that will happen again, okay? So let me know if you see any issues with the camera or with the microphone so I can fix it right away. So and the video will be posted after the class so you can review them if you miss any point. Okay, look at the syllabus and also the announcement on Moodle to see the exact date for the exercises, right? I posted here for exercise 1, 2, right? And test 1, test 2, and final exam. And exercise number 3 will be on the 10th week, and exercise number 4 will be on the 12th week. The exact dates will be provided on Moodle. Okay, grading policy. I have the grading policy that each of the tests will have 30%, and the assignment will have 10%. I mean, the exercises will have 10%, and you also have the bonus point. Yeah. Let's say if you did not do well in one of the tests, try to work for the practicing questions I post for the programming contest team, so you can have some bonus point. Okay, I mean the point for the programming contest training is for you to work more for the algorithm design and analysis rather than the bonus point, right? Of course, you will learn much more, but it's a reward for the students who spend more time for dealing with the the harder problem that we have for the programming contest, right? You know that for the programming contest, we are competing with LSU, we are competing with other universities in Texas and in Louisiana. So we need to work a little bit harder than the problems we have for the algorithm class. Okay, so that is the point. And also, if you want to work for example, Microsoft, or you want to work for Apple, Google, right? And I have many students who took this class and now work for Apple, Google, and Microsoft. Then all of them, they talked with me and they came to me and they said that when they went there for interviewing, they asked exactly the same question that I asked them or I trained them for the programming contest team. Okay? Let's say they gave you a problem, asked you to design a good algorithm for solving the problem. And that is their interview questions, right? So if you want to work for such, very high reputation companies, spend a little bit more time for the harder problems we have for the programming contest. Okay? So let's see what else I need to talk. Okay, one more thing before we start. So today we will start a little bit early. Yeah. Before coming to the class on Tuesday, I want you to review the insertion sort algorithm and also the selection sort algorithm. So next time we will try to design an algorithm for insertion sort and analyze it to see whether or not insertion sort is correct, whether or not insertion sort is a good algorithm, right? Of course it's not, but why insertion sort is not a good algorithm? So that is what we will try to do next time. I posted the lecture note already, so you can look at the lecture note in advance. That's fine, but I want you to look back into the insertion sort algorithm you learned in CMPS 161 and 280, mainly 280. In that we have insertion sort, how it works, right? So review the insertion sort and also selection sort before the class on Tuesday. And I'll see you on Tuesday at 3:30. Okay? Before we finish, any question or anything you want to raise? Say, besides the topics I listed on the syllabus, what else you want to learn? Okay, I'm open to that if you want to learn more. Any question or any suggestion? Okay, I will post the video and let me know if you can see the video clearly, because from now on the lectures will be recorded and posted after we finish. So usually it takes about 4 hours for Google to record the video and then clean up the video, right? So usually I will try to post the video at about 9-10 p.m. depending on when I receive the video back from Google. Okay? So if not, then we will stop here for today and I'll see you on Tuesday. Okay? Take care and bye-bye.